Here we are at the top of page 3 for section 4.1. We're in the chapter on graphing, we're in the chapter on linear equations and inequalities in two variables. So now we're dealing with x and y, and this first section is just graphing linear equations in two variables. We're just doing some basic work in starting to graph the lines. So far we've looked at what does it mean to have two essentially number lines put together, and one in the x direction, one in the y direction. It creates this coordinate grid. We've looked at how do you plot points and what are the addresses of those points. So we get these coordinate pairs, these ordered pairs, these coordinates, x coordinates and y coordinates, which tell you how to get from the origin, 0, 0, to a place in the grid. And now we're going to start with the most basic idea of how to actually graph the line, how to come up with a visual picture of all the x and y pairs that work in this equation, all the ones that make this true. And this, we're in 4.1, this is the very beginning method, okay? So the goal in mind here, we want to keep that goal in mind, and that is to graph linear equations. And what we really are doing there is we're drawing the line that's going to show all the points x, y that work in the equation, all the solutions to that equation. Okay, so that's what we mean by graphing. Okay. So if we've got, if a particular equation represents a line, to come up with that line, if you think about, you know, the coordinate, the graph here, you don't just want to be randomly picking points, right? There's got to be something a little bit more strategic here until we actually land on the line. We don't want to play battleship. We want to have a little bit more strategy than that because we don't have a full afternoon just to graph a line, okay? So we don't want to randomly try pairs and see if they're a hit, okay? To try to hit the line. We want to be more strategic than that. Okay. Eventually, we're headed to what I call instant graphing, and that's using our friend version of the equation, y equals mx plus b. Okay, it's known as slope-intercept form. I call that our friend. There's the formal version, the standard ax plus by equals c. There's the friend version here, the slope-intercept, and then we'll look at a third version, which is your fallback plan. It's if nothing else is working, you can rely on the point-slope form of the equation. And that's where we're headed, is to instant graphing. You'll be able to graph these things in 5 seconds or less, okay? But we aren't quite there yet. We need to kind of build our way there. So for now, we're going to pick points. Okay, and I'm going to say we're going to pick strategic points because we don't just want to randomly pick numbers. We want to pick numbers that work to our advantage. So what you're going to see is directions that say graph each linear equation by finding at least 5 solutions. Okay, now again, this is our beginning step. This is in 4.1. As we get towards our final goal of being able to be really good at graphing linear equations, we're going to get to where we can instantly graph, and we will no longer need all 5 solutions. But just so you can build your knowledge of what it is we're actually doing, we start with this method, and this method is known as coming up with a table of values. Okay, so you're going to start by drawing a little column here of x and y, and what you're doing is you're going to create a bunch of x, y pairs. You're going to create a bunch of coordinates. Okay, so we're creating, or really we're finding 5 pairs x, y that work in the equation, and then we're going to put them on the graph. We're going to plot them on the coordinates, the coordinate grid there, the Cartesian coordinate graph here, and then we're going to connect the dots to draw the line. Okay? So there's 2 steps to here. One, you pick the x values. Okay? And my suggestion is that you pick a negative, another negative, 0, positive, and a positive. Typically you would see -2, -1, 0, 1, and 2. Keep the numbers small so they're easy to deal with. But I did mention we're going to pick strategically. There might be times where you don't pick certain numbers because you want it to be easy to figure out what your y values are. You don't want to make a arithmetic mistake coming up with your y values. Okay, so I would recommend that you try a couple negatives, 0, and a couple positives. Then your second step is you're going to be able to plug in each x value to the equation and find its corresponding y value. Okay, so you're going to plug that in and get your y value. Plug that in, get a y value. Plug 0 in, get a y value. Plug in your first positive, get a y value. Plug in your first positive, get a y value. Okay, and then your coordinate would be that first negative number and your resulting y. And then your second pair would be that second negative number and your resulting y value. And then you'd have 0, comma, whatever that resulting y value is, etc., etc. Okay, you'd have a positive, etc. So let's see what that looks like. Let's do this first one together. Y equals x minus 2 is the equation. Our goal here, keep in mind the goal here, is to graph the linear equation, which means we can expect a straight line. Now this happens to be in y equals mx plus b form. In just a few sections you're going to be able to look at this, skip this table process completely, and go straight to the graph. Okay? But for now, let's just get familiar with what it is we're doing in terms of what do we mean find x, find y, what is it that we're finding. Okay? So we start with picking our x values. Okay? I would recommend 2 negatives, a 0, and 2 positives. And in this case, there's nothing fancy happening to x. Okay, there's no fractions or anything involved. We'll do a fraction at the next video. But so for now, it's fairly safe to plug in -2, -1, 0, positive 1, and 2. Just keep the numbers small and simple. Small, simple, strategic. There's nothing strategic about this one because there's no fractions involved. That's where the strategy would come in if you've got fractions or decimals or that kind of thing. Okay, to keep the operations easy. Okay, so now what you're going to do is you're going to take that y equals x minus 2. So your y value is going to be equal to your x minus 2. Your y value is going to be equal to your x minus 2, no matter what that x is. So I'm just going to set up my y equals x minus 2 and plug in those x's. I'm going to put in -2. And I get -2 minus 2 is -4. Again, I took the -2, plugged it in for x, did what I was supposed to do with the equation, -2 minus 2. That result is my y value. So my coordinate is -2, -4. That is a point that works in this equation. It's a point on the line that you get when you graph this linear equation. Let's plug in -1. Plug in -1. -1 minus 2 is -3. I get the point -1, comma, -3. Here's my x, here's my resulting y value. This pair works in this equation. If I put in -1 for x, -3 for y, I get a true statement. -3 equals -3. It's going to be a point on that line. I plug in 0 for x. 0 minus 2 is -2. So I put in 0 for x. I get -2 as my resulting y. That means this ordered pair, 0, -2, is a point on this line. I've got 1 as an x. Again, these are x values I picked so that I could see what was happening with the line. I picked the x, I'm putting them in, I'm going to get my y that's paired with it, and that'll give me my points that are on the line. Not all of them, but just gives me a sample of them, enough that I can draw a line with confidence. 1 minus 2 is -1. And I get the point 1, -1, x and y. Put 1 in for x, you get -1 out for y. You put 1 in for x, -1 for y, it makes a true statement. Okay, whatever makes more sense, how you want to think about that. X equals 2. 2 minus 2 is 0, so I get the point 2, 0. Plug in 2 for x, you get 0 out for y. Or put in 2 for x, 0 for y, you get a true statement. This is the ordered pair that works in this equation. So now what we can do here is we can plot these points. Here's my coordinate graph. I've got my x going in the left to right direction. I've got my y's going in my up and down direction here. And I plot all these points. So I've got the point -2, -4. To the left 2, down 4. There's my point -2, -4. Next, I've got my point -1, -3. -1 to the left, 3 down. That is the point -1, -3. My next point is 0, -2, so don't go anywhere left or right, just go down 2. So there's my point 0, -2. Next I have the point 1, -1, so I go to the right 1, down 1, so that's the point 1, -1. And finally I've got the point 2, 0, so I go to the right 2 and then I stay put. I don't go up or down from that. So there's the point 2, 0. And what I've done is I've tried enough points that I'm very confident about what this line looks like. It is not just those 5 dots on the page. You draw the line, you extend the line with arrows to show all solutions. Every point on this line, everywhere you could drop your pen in, whether it be in between the grid lines or it be a negative, positive, fractions, decimals, everything on this line that goes forever, every single little point, if you were to zoom in and capture the x coordinate, how far it is from the origin on the left or right, and then its y coordinate, how far it is from the origin up or down, that x coordinate and y coordinate, if you were to plug it into this equation, it would make it true. Every single point on that line. Okay? We'll do some more at the bottom of page 3. See you there.